you. We want to learn more about what you're doing and figure out how we can work with you to, benefit all of us here and more generally in the data science initiative. Thank you. Thanks, Marcy and Jean, for keeping the library connection alive.
Yeah, great. Well, thank you, Marcy. Thank you for that introduction, Brian. And Marcy, thank you for inviting me. And thank you all for coming here and listening to me and eating some pizza. So I'd just like to sort of start by saying, so I've actually been working at the library for over 10 years now. I started as an undergrad reshelving journals, and have worked my way up. So, and I've been my title changed. My title was Spatial and Numeric Data Librarian until last November. So I've been in this role for 5 months. So I kind of wanted to sort of talk a little bit about the library support for visualization, tell you a little bit about my background, some of the current things that I've been starting on these past 5 months, and then some thoughts I have about sort of going forward, and then I'd like to save some time at the end to sort of hear a lot about what you all are interested in and how we can support you in the library, because I think there's a lot of support from the people higher up the chain than me for me sort of going and moving into new fields and studying new things and learning new technologies and stuff like that. So
Great.
I'd be really excited to hear what you all are interested in and what you need and how we can support that. And if you want to think about that while I'm sort of going through my stuff, I should maybe warn you, I've taught undergrad, so I'm really good at sort of standing here until someone says something.
So somebody throws something.
Yeah, throws something or leaves or says something. So if you want to think about sort of the sort of things that that we can do to really support your research, that would be great. And I'll definitely save some time for us to talk about that. So I just wanted to, I know you've heard from some of these people, but I just wanted to sort of place my role in relation to a sort of larger ecology of supporting visualization. So I think Ted Hall maybe came a while ago and spoke about the 3D lab. So there's the Digital Media Commons, which is up on North Campus, and for, is it like 7 or 8 years has been part of the library? Not that long. A number of years, that is more than one.
We could parse that out, but it's been,
has been part of the library. And they have all sorts of exciting sort of 3D things with the cave and the virtual reality goggles that they've now been sort of investing in and these kind of things.
3D printing?
3D printing. And there's also, we've been talking, this sort of started before I moved into this role, but I've been engaged in these conversations about, they are in the process of working with Kane to put in what they're calling them biz hubs, and they're essentially going to be kind of high resolution monitors, lots of RAM and processing power, and some software that you can sort of go and access, I think, at like all times of day, and and sort of have a machine that's dedicated to doing sort of visualization work. And then the hope is that if that sort of works on North Campus, that will at some point put one here on Central Campus in the library. So that will be a resource, and hopefully we'll get that. And then of course they're the Taubman informationists, which is Marcy and Jean, who are here, and Marcy does a lot of work with Cytoscape and other sorts of visualization things, and definitely both of them know bioinformatics a lot better than I do. So they're a great resource. And then I moved into this role back in November and became sort of a visualization librarian and trying to sort of kind of knit all these things together and support visualization and really figure out how the library can sort of be a central location for this. And I think one of the main benefits of having it in the library is that we are sort of undisciplined in a certain way. Obviously we have our subject specialists, but I think that a lot of times what happens with some of these things is that both the infrastructure as well as the techniques gets kind of reinvented in individual disciplines. And so my hope is that the library can be a place that we can sort of bring people together from multiple disciplines, and with my work and the work of Marcy and Jean and the work of the DMC, that we can sort of make this be a campus conversation about visualization and visualization techniques. And then it's not in the library, but I also wanted to mention, because we've been working sort of more and more closely with LSA IT, now has the advocacy and research support people. Is there someone who's assigned to you all? Do you know? maybe there will, I think.
No, I mean, this is important for the data science initiative.
I think
for a lot of reasons. So if you could say like 2 lines about this, that'd be good.
So my understanding is that essentially the advocacy and research support was actually modeled on the idea of library and subject specialists, so that there are LS&A IT individuals who are assigned to departments and essentially do sort of IT advocacy for faculty in those departments. And I think maybe they started with a small set of departments, and the plan is to sort of grow it. But for instance,
these guys are embedded in the department or go back and forth? Hybrid?
They go back and forth. So I think their offices are all in LS&A. And then, so for instance, I've been in conversation with Seth Myers, who does statistics and he might do physics and a couple other departments. But one thing that he's done is he's put sort of one of these visualization workstations in the stats department. And it's sort of tucked away in a little office there, but the idea is that it's sort of a high-performance machine, and he has it set up with CUDA so that people can do GPU processing and stuff like that for real-time visualization. So I think that, that this will, as we move forward, will definitely be a large part of this, is sort of integrating LS&A IT and the support that they
Okay, so this is good because it's another way we can look at this. It's very helpful for me. Is you guys have a ecosystem that you're building, and one way to look at it is you've got from a more administrative point of view is you've got Kane and Kane and there's going to be Viz hubs out there. You've got the Taubman folks from health sciences libraries, and so the health and biomedical science piece, medicine, and so on. Public health. Then they actually got some LSA roots. So from a guy who has to go and explain it from a campus perspective, it's very convenient, And then there's something that holds you guys, the glue in the middle.
Yeah.
Yeah. Okay. Good.
Yep. Yeah. So this is kind of the landscape as it stands down. Of course, it's a quickly evolving ecology, but I think that there's a lot of different people, and also I didn't put up here, but I know that ARC is very interested in these kind of things as well. So there's a lot of people who are excited about this and interested in it.
It's the Office of Advanced Research Computing. Consider me the ARC rep for this meeting.
Oh,
okay.
Great.
Okay, good.
I just have a question about the Viz hubs.
Yeah.
So those are going to have the beefy computers, the monitors, the things, and some software, but is there going to be some part of that that's available for development of new things? If I have software I want to try, or if I'm writing software, is that going to be possible?
I don't know for sure, but I would very much like that to be the case. I mean, I think, especially a lot of the, I think, like really like sort of interesting Viz stuff is actually stuff that people are, hard coding and stuff like that. And so being able to compile and execute stuff on there.
Okay, good. We'll make a note of that.
Would be really, and I can report that back as well and advocate for that. But I think definitely, because I feel like, a lot of for me, I try to kind of constantly be doing visualization projects to like know, sort of what the landscape looks like and stuff like that. And I think most of the interesting things, involve actually programming something and compiling it. Of course, there's lots you can do with sort of pre-built software, but definitely.
Yep, good. Yeah, we want to move beyond, and we want to have a brand for ourselves too. All right, good.
So this is sort of a way that I've kind of been thinking about visualization and this sort of the spectrum of visualization. And my hope is that the library, as well as these sort of other campus partners and individual departments, can make sure that we're sort of covering this entire spectrum. And so over here on the left, I have something that I'm especially interested in, and it's sort of something that I think sometimes when people are talking about visualization, they like half the people mean this thing and the other half of the people mean this thing, and you don't realize until after the meeting that you were talking about two different things. So I just like to be clear that I think these are all parts of visualization. So I think on the one side, we have these sort of design questions. How do you take your data, and even if you're putting it into a black and white graph for a print journal, how do you make sure that communicates the information you want? And I think especially in work with undergrads, I think this is incredibly important, because because in addition to the sort of the research that we do, we have all these undergrads who are going to go out and interact with the world and read New York Times articles and this kind of thing. And I think them being able to I just mean because the New York Times has really been investing in like data journalism, and they now have all these graphs and maps.
Oh yeah, well they hired Tufte years ago to help them. I mean they made that was going back 20 years now.
Yeah, and they have Mike Babstock, I think is
Yep.
his name, who's sort of doing all this interesting stuff with web visualization. And so I think, on a campus level, I think it's really important that our undergrads can critically engage with that discourse, and they can, both be producers of visualization in whatever sort of field they go into, as well as critical consumers of that information. And while that might not be exactly relevant or directly relevant, to the day-to-day work that you all do, I think it's an important part of what we do on campus, and also, I mean, for the sort of communication that comes out of all disciplines, both sort of for disciplinary audiences, but also as it sort of migrates out to the general public. I think being able to express data visually is an incredibly important thing. On the other end, it's sort of these more kind of technical questions of high performance computing, 3D environments using GPU processors, multi-cores, and sort of real-time, multi-terabyte visualization. And then in the middle, I think there's a lot of work that's not sort of the high performance computing, but being able to do sort of high quality and in a reasonable amount of time, doing sort of data munging and data scraping, and moving data between different types of software and between different formats and stuff like that. And
There's
especially
this new term called data wrangling.
Mhm.
Yeah. I think might overtake munging, but it's the same. It's a huge problem.
Yeah, and especially I think as the sort of number of formats and the types of treating data proliferate, being able to go back and even a lot of my sort of work prior has been kind of in the social sciences, and there's all sorts of data that's still on tapes, and people in like the data dictionaries are just sort of these printed things that have been rescanned, and you have to figure out how to convert the like little endian binary into something that a modern piece of software can use or something like that. And so I think there's all sorts of work here in the middle that both is a requirement to sort of make these kind of static design type things, as well as to move data into our sort of high performance environments. And we're also in the process at the library. I think we're hopefully going to announce it soon that we're hiring a research data manager who will be sort of part of these larger conversations about how we manage research data and make it accessible and make it reusable. And I think that this will sort of all be part of a much larger data conversation about how we
Yeah, so it's interesting. It's putting the data in the middle. The data and information and access to that in the middle. And the one word on this chart that's missing kind of, which is inherent, is analytics. I mean, this is a form of visual, this is kind of visual analytics.
Yeah.
Is that where you're going?
Yeah, definitely. And I think, I think that this sort of ecology is part of a larger set of conversations, both on the one hand, sort of these questions about data management, how do we, keep track of data, make sure that we're reusing it in ways that are, that are reasonable based on the data. And then I think there are also other questions about the relationship between predictive modeling, analytics, visualization, and hypothesis testing. Because I think that there are ways that, especially, I don't know exactly how it sort of functions in biology, but definitely in the social sciences, there are sort of all of these tensions between, especially if you do these sort of predictive modeling, like the way that Google treats things, and then how that interacts with hypothesis testing, because they're very different ways of interacting with data, and sort of how we expose data to those things and how we visualize them, and that sort of thing. I think will be sort of larger questions that still need to be. I know there's sort of right now kind of a crisis in social psychology, because a lot of the statistical methods that they're using are actually people have figured out that they're actually not working as well as people thought they
Yeah,
were.
we're more deterministic.
Yeah. Well, there was recently this paper. I think he's at the Wharton School, who he went and played different groups of people, like 3 different songs, in order to prove that people who listened to one of them were younger than people who listened to the other one. But it was just through sort of kind of messing with the p-values and correcting for all different sorts of things until they got a result that clearly couldn't have been true. And so there's I think some interesting questions, especially in the social sciences, about sort of the relationship between data and statistics and that kind of thing. So I think all these questions about analytics will have to be sort of in that context. So I wanted to say a little bit about my background, just so you know sort of where I'm approaching these things. And like I said, a lot of my work prior, so I've been a librarian. I did my master's here at the Information School, and where I studied information analysis and retrieval. So it was a lot of network analysis, text mining, these sorts of things with strong GIS components, so geographic information systems and mapping. So prior to becoming the visualization librarian, I was a spatial and numeric data librarian for 3 years. And a lot of my work had to do with sort of mapping and taking data and making maps and doing spatial statistics and this kind of thing. This was a map I made where you can actually zoom in. It's where everyone in the US lives and works. And so it's like one dot for where someone lives and then a different colored dot for where they work. And it's like you can zoom in and see like downtown Chicago is completely blue because no one actually lives there. They just work there. It's true. Have you ever been
Actually,
to
you know, I want to correct that a little bit. I learned something quite weird. Actually, you should think about this. I was in Chicago recently visiting with some colleagues downtown Chicago. And then, they live out in the burbs, kind of north of, Evanston. And, but they both actually had apartments downtown. They both worked at the University of Chicago on the South Side. And their primary residence was in, north of Evanston. But the commute was so long that during the week, they often went to their apartments in Chicago downtown. So you want to check that out because I was like, what? This is like, they were saying, why don't you come over to Chicago and like run this and that? It's like, whatever, and then I'm going to like have an apartment downtown in my house over here. It's like, but think about that.
Yeah, no, I mean, that sort of thing gets lost in this sort of trends.
Yeah, it happens a lot. So it does. So it's I didn't mean to distract you, but it's just kind of an interesting little data point.
Yeah, no, I mean, I think it's actually very relevant because I think so often, when we move data from one context to another, these sort of little things end up getting lost because maybe. This is based on IRS data, so it's based on where people's primary residencies are, and those sorts of nuances I think oftentimes get lost, and so being aware of them is incredibly important in all sorts of contexts. So, like I said, I also did a fair bit of work with sort of network analysis, and I'm very interested in sort of network metrics and these kind of things, network layouts. This is a map of the internet. This was this OPTI project where they tried to, not the World Wide Web, but the actual server infrastructure behind it. And I think that the colors are different continents. This might be from 2003, but I think there's for me, I find a special interest in this sort of network analysis. And Marcy and I have been, for 2 years now, we've actually been co-teaching a cytoscape workshop for social scientists. So it's really a lot of fun because Marcy knows the kind of cytoscape a little better than I do, and I know a little bit about how the social scientists are interested in network analysis. So, and then also, like I was saying, a little bit of text analysis. This was just a project mapping, I think, science articles on Wikipedia and whether or not you could sort of determine how likely they were to be articles about science. And then I think it's just the network layout over that. So I just wanted to say a little bit sort of about some of the technologies that I'm most familiar with and that I've been using. I use R a lot. I don't know, do people use R a
It's
lot.
big here.
And I've been teaching a sort of a workshop for a while on visualization techniques using R. It's a very sort of lightweight introduction to R, just sort of mostly for people who either don't use R or are interested in sort of how to visualize information. Cytoscape, and I use Hayek a little bit. I don't know if anyone.
Tell us about that. Anybody know that one?
Yeah. What's that?
Yes.
Yes.
Jeff? What is it?
It's a network visualization.
Uh-huh.
And it's also, it does analysis.
Hayek.
Sometimes
Hayek.
it's out of the University of Ljubljana in Slovenia. I think Hayek is Slovene for spider, I think. So.
Yeah.
But it's, I don't know, it does some things that I find hard to do in Cytoscape. And so I think it's also a good example of sort of the kind of the weird ecology we have of tools for doing visualization, that, you know, that sometimes there's like one thing you might want to do in one tool, and then there's another tool that, like, if they were Venn diagrams, they'd be like almost on top of each other. But if you need to do that one sliver or something like that.
Happens a lot.
And so this is one thing I'm really trying to sort of do, is stay on top of these tools and stuff, so that, you know, it can help make recommendations. Because I think, at least I've found a lot of these tools sometimes come out and they've like put in addition and subtraction, but they haven't gotten around to adding like division and multiplication. So like you're working on some super beta version, but it has a lot of hype, so everyone's downloading it. And just keeping track of what these different pieces of software can do. I've also been doing a little bit of work with sort of web technologies for interactive visualization. D3 is actually Mike Babstock, the guy from the New York Times, his sort of JavaScript plugin for doing all sorts of interactive and real-time graphing charts and networks and stuff like that. And I think there's some really interesting work to be done here on sort of a lot of the web technologies. I mean, just because of using JavaScript and things over networks, oftentimes can't really support very much data at all. So you're either looking at very simplified views of data or very small data sets. And I think there's some interesting work to be done in sort of pushing large amounts of data to web visualizations and stuff like that. I don't know, has anyone here ever done anything where, you know, you've had some data set or wanted to represent something and needed to push it to the web for sharing in a way that you can?
All the time.
Mm. And what tools do you use for that?
Well, we've actually developed many tools. You know, we have NCIBI itself was a funded national center for many years by the NIH that allowed us to develop tools that, you know, ultimately became web services that are used throughout the planet, including some of Alice tools that, you know, I heard yesterday you have 4,000 users in Netscape, or at least registered users.
Okay.
We actually developed them, and they're used all over the planet. And some of our work is involving platforms to allow for analytics to be linked with various kinds of heterogeneous data. They're used all over the planet too.
Oh, great.
Yeah. So we can actually help with this list.
Yeah.
Yeah.
No, and this is sort of, like I said, it's 5 months seems to go by incredibly quickly here at U of M. It seems like it was just yesterday that
32 years.
Yeah.
Yeah.
But so I'm very interested in adding to this list, you know, based on sort of these conversations and what you all need and you know and what sort of services we can support. I've been, and this is sort of gets to your question about coding. This is I've been doing a fair bit in processing and moving to Cinder, which is a C library for doing data visualization, and it's like being used, I think, for a lot of like interactive shows and stuff. Like there are a number of bands that like have programmed their like visuals in Cinder for their, you know, their rock concerts or whatever. But it's nice because it's in C and compiles directly, so you can get some nice sort of real-time performance out of it. That you
I'll tell you one that we're working with a lot, and it was developed by a good friend and colleague. You know, actually, you know, the guy who really did a lot of the work is Ivo Dinoff, who's here now in the School of Nursing. But you know, the lab is called the Laboratory of Neuroimaging, Loney, and this is now it moved from UCLA to USC. And they have an international center for three-dimensional visualization of, you know, anatomic elements, largely the brain, neuroscience, and we have pretty big Loney installation here on campus and a lot of work. It's one of these plug-and-play pipeline tools that is widely used for looking at radiographic imagery, or we are now extending it to microscopic imagery and 3D and then linking in analytics. So it's one we can throw on your list, and we'll work with Marcy, you know, and Jane, and get that available to you. And we actually have a production Loney server here on campus.
Great.
So that would be a very quick win for you.
Yeah, that sounds.
Have you ever looked at the Anaconda distribution of Python?
No, I haven't.
You really should.
It's designed for big data analysis and visualization. It's got
Okay.
lots of tools added on.
Oh,
It's-
that's great.
You know, that's another one that's definitely on, and Jeff turned me onto that, and it's cool. And so we're going to throw that. The Loney and Anaconda will both be elements of the infrastructure that we'll want to work on, you know, with you in terms of the data science.
Yeah, that sounds great. Maybe I shouldn't admit this, but I'm going to. So because of my sort of background with text analysis, I still do a lot of my scripting in Perl, and I've been meaning to make the jump to Python. So this is
So now we're pushing you.
yes. No, this is good.
We're taking a high-end, next-gen, extreme Python, you know, Anaconda, you know, and you know, so we actually have a class you might want to come and sit in with.
No, that sounds great. It's been a jump that I keep meaning to make, and now this sounds like the reason.
It's the time.
So they've got a module in there that does D3 from Python.
Oh, great.
Oh yeah, just think power tools.
Yeah. No, so.
We're not calling Loney right now. You know, we have this Transmart platform that's all around the world now, and starting to call these power tools. So you know, you got tools and then power tools. So Weka, we've heard about that one here a few weeks ago. I'm calling a power tool. I mean, you know, it's kind of a community. Text processing, Lucene would be a power tool.
Yeah.
You know, and so what I think we want to do is be able to work with you guys to develop the power toolkit.
Kind of to follow up a little bit on that, I like that idea very much, and what you said earlier about, like, you know, different types of visualizations being used in different fields, in scientific disciplines and stuff. So it seems to me that you're in a very good position to kind of maintain a set of examples or library, if you will, of these different visualization tools and approaches, because I'm sure we can learn from each other rather than reinvent that within each individual discipline. So I guess, you know, is that part of your sort of, you know, charter to kind of, you know, collect some examples of these tools? So for example, you know, we do things in Cytoscape, as you mentioned, right? And it does some network analysis type things, but we know that our colleagues in physics and, you know, and so on and so forth do a lot more with that. Yeah. And, well, this is just one example, and this is what I happen to know, but I'm sure there are other things that I don't know about. Yeah. And I think that would be sort of, you know, very much in line with main library goals, if you will. So,
yeah, definitely. I think one thing I would really like to do is, you know, we sort of have this tradition of collecting books and stuff like that, but exactly to sort of collect tools and collect libraries, and maybe even, you know, there are specific sort of scripts and stuff that would be helpful across campus, and, you know, and developing those. Libraries, and collecting those.
Absolutely.
It seems like it would be a good idea, especially for cross-disciplinary type things.
Yeah, and I mean, and everything from methodology to, you know, sort of a library of libraries, if you will.
Yeah, absolutely. Very cool.
But so going forward, I wanted to say a little bit more about sort of some of the work that I have been doing. So I've been sort of meeting with people and doing consultations. This was not the consultation I did, but there was a poli-sci student who for her dissertation is doing some work on sort of the ways in which sort of political theory actually goes through the poli-sci literature. So she was interested in doing some bibliometrics and sort of seeing how concepts sort of spread through the political science literature. This was just an example I found of, I think it was out citations from Nature, so you can see the sort of the different journals. That
I see. So these are citations at the end, the reference section of Nature, and where they're going on.
So
that's really interesting.
And this is the sort of thing I think especially that, you could obviously gather the data, but sort of the way in which you visualize the data is so important for sort of telling the story and making it accessible to people. So I've been sort of doing these kind of consultations with people who have sort of questions about how best to represent their data, either from a sort of a visual question, what sort of graphs and charts should I use, to a software question or these kind of things. Let's see. So, okay. So this was another project. This was very much in the humanities, but I've been working with a professor who has been doing all this research on Ira Aldridge, who was a 19th century African American actor who went all over Europe and performed, and she wanted to sort of, and she was teaching a class, she got a grant. And
so who is the faculty member?
Her name is Anita Gonzalez. She's in music and dance. And so she wanted to have this sort of interactive website where you could, and I have some students who are working on it, they're still working on it, but you could click on these and see sort of what performance he did in that location and when it was. And she has a class where they're sort of recreating some of these performances, so even having video of the performances and stuff like that. But it was quite an involved sort of programming project to make this sort of interactive map, and we put down this sort of old map of Europe. But I was able to hire 3 students for her. I mean, it was with her grant money, but I found the students, and I've been meeting with the students once a week, sort of talking about the underlying web technologies and how to scope the project and stuff like that. So it's definitely an example more on the sort of mapping humanities side, but it's a model that I think could be beneficial going forwards, especially
very important.
If someone was interested in doing something in maybe a like web stuff, if one doesn't do a lot of web stuff or something like that.
Can I ask you a question? Because I was pushing this with the data science initiative, and it's got to go, and it's this whole digital, humanities aspect and arts. How much of that is happening here, in various departments like English or, art and architecture or music? How many folks are getting into that?
Yeah, I think it depends on the discipline. I mean, some disciplines no one, and other disciplines I think a lot of people are excited about it. So I think it's still something that U of M is sort of trying to figure out where we fit into a larger sort of national landscape around digital humanities.
Yeah.
And exactly what sort of support we're going to offer, and how it's going to interact with tenure and stuff like that. But there's definitely people who are interested. And I mean, like Anita. This was her first year here, and she was really excited about this kind of work. And at the Institute for the Humanities, they've been doing, they've had a talk series called Digital Pedagogies, I think, and so there's been a lot about sort of teaching through digital tools in the humanities that I think people are getting excited about.
Thanks.
So, and then in terms of going forward, and this is where I kind of want to hear a little bit more about what you all are working on. I think there's all sorts of exciting things from these sort of infrastructures. I put this up. This is, I don't know if people use hex binning for plotting. Essentially, it's a technique for dealing with overplotting. So if you have, if you have a scatter plot and it would just look super dense, what you do is you divide your graph space up into hexagonal bins, and then you just count the number of points in each hexagon. And it ends up being sort of a really nice strategy if you had just such a density of...
So each hexagon's like a different color or gray value.
Yeah. So here, I think...
These represent different strata of some kind of data element?
Or no, it's just a scatter plot. And see, like the darkest ones represent 7 points, and the lightest one only has 1 point in it. But you could imagine that could be like 7 million points down to 1 million points or something.
It's sort of a 2D rendering of, you could think of a 2D rendering of a 3D visualization. So if the points at each intersection were stacked, you've now collapsed that into a 2D visualization by color to represent that.
But it's more for if you have a 2-dimensional scatter plot that has a huge overplotting problem. So you have like, a million points right on top of each other, and there's no way to tell that here there are 1 million and here there are only 5 because you have only so much resolution. So what you do is you divide your two-dimensional scatter plot up into hexagons, and then you just count the number of points in. Well, I mean, you have the computer count the number of points.
I see. So it's a way to, okay, I hear what you're saying too.
You could render it in 3D as height, in this way.
You could. But this way, they'd use a different color, and so that top one is 7 million points. So you don't have to graph 7 million points down.
Yeah. And so it's good both for.
So it's kind of like some kind of log scale that you're imposing.
So it's also sort of like a heat map, but more discrete instead of sort of continuous with.
Yeah. It's very much like a heat map, and so the nice thing is that you can sort of see a lot of points in a way you couldn't necessarily if it was in a printed journal, but also it's a lot easier computationally. So you could have an interactive visualization of millions of points in a way that you couldn't if it was just a raw scatter plot necessarily. And the reason I put this up is because it's really just a simple concept. It's not it's not like
the way you've got it now. It's generic, because the dimensions of the hexagons are x and y and height.
Yeah. But this was I think the earliest reference I was able to find was in the early 90s. So I think it's interesting that like this graphing technique is just about 20 years old. So there are still all these sorts of, in addition to the infrastructure around visualization, there are still sort of innovative ways that we can sort of figure out to actually even just represent information. And I think having that be sort of part of the conversation, I think is something that's really interesting. And there are all these components from how we represent the information to how we're actually going to go about representing it once sort of a representation is selected and makes sense and communicates the things that we want to communicate. But the sort of most important thing and the thing that I'm most interested in today is sort of hearing about what sort of problems you all are running into, what the library can do to support your work, and what can we do to sort of help you with your research and your teaching and sort of helping this kind of ecology coalesce into something that's beneficial for everyone.
Okay. Super. So guys, why don't we, some of you take over. Let's, everybody needs to visualize something. So, and it's a good offer here for some help.
I mean, are people running into infrastructure problems? Like, are there visualizations you want to do, but you don't have the processing power to do? Or you don't have someone to write the MapReduce program to run it on a cluster?
Well, we're not doing a lot of Hadoop and MapReduce yet, and so you might take a minute or so and describe how that could be used.
Sure. So we have here through our advanced research computing, they have the Flux cluster, which is a multi-core cluster, and there are a couple different techniques, but one of the sort of generic techniques for parallelizing things and running them is a process called MapReduce, where essentially you have a function that splits up your data, maps it out to different cores, and then each core essentially runs a reduce function on it. So it somehow processes its little silo and then reports the results back essentially to the map function. So you could imagine if you had like, 1 trillion numbers to add, you would split it, 3 trillion numbers.
So we're just so you know, we're probably the largest consumer of flops on campus.
Oh, okay.
We have one research lab down the hall that's got, I'm going to shut off a few of the cores, but right now I have 3,000 cores just for one lab. So, and we all are doing bioinformatics analysis here, so most of the faculty have fairly sizable accounts on plots and other specialized machines.
Great.
So just so you know, you're kind of in the high-end zone right now. So that means that, we have special needs for visualizing kind of lots of data points. And, and then bioinformatics is about analyzing, streams of information, the genome. And now when we started this whole thing, we were, waiting for the day when the genome sequence was released, but now we have the 1,000 genomes, and so we can do statistical analysis of variation of thousands of genomes. And one study that, I'm working on where we're analyzing 17,500 genomes.
Wow.
Yeah, so that just puts a context.
Yeah. Yeah, no, I figured you all were high-end consumers of that sort of thing.
So it could be, it's another name for us, troublemaker.
So I could offer a suggestion because you are a group that is very familiar with high performance computing and develop your own visualization solutions. But I do think that a good way to partner is understanding that communication level. So the library has experience with heuristics, right? And getting the message across. Just because you can make it look pretty doesn't necessarily mean it's getting the message across necessarily. I think that Barbara Merle is a great example of a great partnership with somebody who's trying to get functional tools like Netscape and all these other things in terms of the great tools that get produced to be understandable by people other than bioinformaticists.
Yeah,
so like
way,
scientists.
Another, just translating it just slightly, what Jean's saying. Usability, human-computer interface. I mean, that's not, we brought Barbara into our group years ago. I mean, before Barbara, there was this fellow named Carl Berger who was in our group, and I think Alex, if you remember him, he was actually the dean of the education school who worked on usability analysis when we had the visible human. We found out that, the gross anatomist would use the 3D cadaver in a different way than the dentist would use it, than the nurses and so on. We did a study and published that years and years ago, and it was really usability analysis, and different communities, actually, understand different things in the visual data.
Yeah.
Kind of stuff. And so, you're absolutely right. So that's one of the things that we're, and I think another thing that we're getting into more and more, certainly with Transmark, and Barbara helped us with this in the early days, is lots of times, the standard means of publishing data break down when you have, big data and visualization. So, posting YouTube training videos, and other things is turning out to be a real need for us right now. I mean, it's huge, but, our 1.2 release, this is turning out to be a huge challenge for us. Is how do we document what we're doing in new ways, and the workflow aspect. That's probably the biggest thing to worry about for us right now is, the big challenge for us right now in the field, the biggest challenge of all, is the so-called reproducibility challenge. So you probably heard that, in nature, science, and cell, and certain classes of studies like clinical research, more downstream from us, but, it's bioinformatics too. We publish a paper, but nobody can really reproduce it. Why? Because the data was developed in a certain day, and the visualization tool was developed in a certain day. And by the time, folks might not have access to that data and code and, workflow. And so the reproducibility of the workflow, and the whole idea of a workflow becomes important for us.
Yeah, I'm really excited about us bringing in a research data manager. I think I'm going to work closely with that person, and I think that hopefully we can get some leverage there in terms of, because I think you're absolutely right. It's and part of it's sharing data, but we should also be sharing code, and we should be sharing workflows and stuff like that.
Well, we're going to have to, and so we're developing the standard means for reporting that now, so that somebody can click on our workflow and get right back to our data, and very rapidly in the publication, launch our platform and reproduce our study, and then if they want to put new data into the thing, they can. That kind of approach.
And is that being done mostly here, or is it?
Well, by the way, this is, Dr. Collins, our NIH director, was addressing this issue at the Scientific Management Review Board yesterday. We were watching him on TV. This is this, and it's not just biomedical research, but I think it was the pharma companies that really started beating on the NIH, because the pharma companies were taking Nature, Science, and Cell papers. One study, there were several studies. One was a J&J study, one was an Amgen study, but the bottom line is they could only reproduce about 25% of the paper.
A lot of those were poorly designed experiments.
They were. By the way.
Well,
so
no,
that's very important
people
statement.
People are under budgetary constraint, and so they don't do enough replication.
That's a very important statement. So this is leading to things which you should know about. That in the methods sections of papers in the near future, there's going to have to be a much more categoric and explicit, statement of the statistical model and the assumptions than, had been previously. Nature, Macmillan, Nature Publishing Group is leading the way on this. Nature scientific data might be a journal you want to look at that's, kind of doing this kind of stuff now, figuring out how to publish the data. So from a library perspective, it's, I think, an interesting area to think about, you're not just keeping track of all the journals or the books anymore. You would be keeping track of, digital research objects that are really, we're disintermediating to a certain degree the publisher, and you guys are going to, develop a data dictionary and a resource, catalog for the institution. I mean, this is where, 100 years from now, it'll be there. But this is the early days, and so you're the visualization guy. So, that's a very important note on the network. So, I think what would be good is that you got this list. You got R, this is a good place for R. A very good place for R. We teach it in our classes. There's, Maureen's doing a lot of it. It's a standard element in the bioinformatics, R and bioconductor. I mean, it's cut off your arm if you don't have it. So we could actually work with you, and we're developing with Hopkins now an extended R library for our Transmart platform. So we have an R library already we can share with you.
Yeah, that would be great.
And we're developing a bigger R library. So that would be one to develop a catalog against. We could do that right away. It would be helpful for us, even with our 1.2. You've got the Cytoscape people here, and we used to be a member of the Cytoscape, consortium, and pick up the phone and get back into it. Now there's PIAC. Are you using some of this in the course? No.
I think PIAC is probably more social science than it would be super helpful for you all.
Okay, so let me just jump in on that point, because one of the things that we're doing right now, and this is going to be a huge initiative, and I'm sure the president will announce this part of it, is that, the days of thinking of medicine kind of narrowly and health a little bit more widely, but, linking the medical and health data with the environmental data and the social data, is the, which would be economic data, for example, demographic data, this kind of thing. So, in our world, we like to think about, a lot of the molecules that are making the mechanisms for, life. And then we decided one day, gee, maybe we ought to, characterize what we call a phenotype. Maybe even look at electronic health records or something like that. So that's this, genotype to phenotype. But then we said, gee, and then in health and disease. Well, all of a sudden you open the Pandora's box to health. So then all of a sudden, what are the determinants of health? Is it all your genes? I don't think so. So it's like what you eat. It's the environment. Are you smoking? All these kinds of things. And then, well, maybe you're living next to, the mercury, the incinerator down in Detroit, or maybe, it's like they say, what happens in Beijing, is 4 days from Los Angeles. So, we're in this connected world. So if you think about the fact that where we're going to go, and this is Richard Gonzalez now at ISR, it's this biosocial research concept where it's the health, it's the medical and health data. So the health system will supply a synthetic derivative of the health record or the CMS records or something like that. And then you have the environmental data, where the School of Public Health should be able to help us with it. And out into ISR. And so if you think of, so all of a sudden what we're saying is, so this is where your map could become important, for example, because we will push the development of these integrative data resources up from the bottom of ARC. This will be services coming out of ARC, and then research collaborations will start against the boundaries of medical and health, social science and health, or something like that. I mean, that's the vision.
Yeah.
And we're going to present, this vision will be presented in, in a matter of, weeks at the Fleming Building. I think that's part of it. It's not the only vision, but it's a good one. And I think that's something that we're comfortable with here, because we would like to have the opportunity to expand out of our very narrow box a little bit. Okay?
Yeah. Yeah, and I should mention, if anyone is ever interested in doing any sort of mapping stuff, I still do a fair bit of GIS and mapping stuff, and I'd be more than happy to meet and talk about that.
Well, that's important, because you can map against anything, like our visible human, for example. I mean, you know, a map could be any, you know, you could plug anything into that thing. Cells.
Yeah.
The brain. So Obama, one of the things we're going to put in is you know, it's inevitable. We are going to have to get a neuroscience initiative going around here. I've been in a lot of meetings with, you know, we talked to Slissel about it. Hooter Keel's running it. She's been down there at the Fleming Building several times. You know, Michael Johnson, new executive vice president, they're all hearing it. The dean, we've been meeting on it continuously. You know, Obama's got a brain initiative. How can the University of Michigan not have a brain initiative? I mean, you know, and then we have engineering and biomedical engineering and, you know, all this stuff going in and out of the brain. We got the psychiatrists over here. Gotta have it, man. And so the three-dimensional, you know, topology of the brain is, that's why we bring in Loney to the table, or Alzheimer's disease. You know, as an example, what's happening in your brain on Alzheimer's. So I think that's an area that you should be aware of that's going to grow here. So let me just, one more thing. So we can measure some of the genes in Alzheimer's disease. We can measure some of the brain structures. We can measure the cognitive impairments, that kind of thing. But at ISR, we have a longitudinal study funded by the NIH, $70 million. I'm looking at, you know, how people age over time, you know, with various kinds of impairments, cognitive impairments. So if you can bring these all together, and we've got a guy coming in who's going to help us with this GPNE, he's going to start here in the fall. You know, Ivo's working on this. I mean, how can you bring these data together, you know?
Yeah.
It's got to happen. Why? Because Alzheimer's in the United States is going to be $1 trillion a year, you know, hit on the economy by 2050. Okay? So that's why we're doing it. And so I just want to make you aware that, you know, if you think in that space, and you think in digital humanities space, you think about, you know, some of the stuff you can do with the stats and engineers, you know, in the information scientists. So I think the network analysis, Ala was saying, will be huge. And I think next year we're going to hire in that area.
Okay.
All right, is there any other? Well, good. Thank you, Justin, and Marcy and Jean for the vision of bringing Justin and teaching us about this emerging infrastructure. And Marcy, why don't you arrange a little private meeting soon, and we can transfer with Jean, and we can transfer some of these early technologies like Loney and others, and make some links. You know, and you know, the other thing is, we want to take you up on this teaching offer, and you know, the R module thing might be a way to go with that, and we can get a list of R modules that we have and a new list coming from Hopkins. We can get you in our library.
Okay, great. Sounds great.
Okay.
Thank you.
All right, great. Super.
Yes.
That's very exciting what you're doing.